Alright, let's get started. I think probably one video for 4.2, but how soil is formed and how it erodes, meaning how it washes away. Been a big issue. The Dust Bowl, which I think you guys have heard about in your history class. It's all about first, the erosion of the soil that had been formed over eons of flooding that has happened in the Midwest. But let's get back to our enduring understandings. These are understandings that span over lots of things. Remember the state of balance. Basically, in this case, rocks get weathered or eroded into soil. Yeah, there we go. Okay, so changing rock into soil, but then over time soil can undergo processes like compaction that can then be turned into rocks. Sandstone would be one of that, and other sorts of sedimentary rocks. Let me put that as a parentheses, sedimentation. Which then can then be weathered down into soil. So we see, this cycle, right? The state of balance, making rocks, breaking rocks down, turning those rocks into soil. It's a process that just keeps going over and over in balance over time. And one of the things that's happening that's happening right now is the soil eroding faster than it's being replaced. We'll say it's being made. It is being made. That's the big problem. So we have all these really fertile farmlands, and we're not taking steps to prevent wind and water erosion of that soil. It goes away, and we're not able to replenish that soil. We can, in some ways, make up for that with fertilizer and other sorts of techniques, but it's not as sustainable as the way that soil used to be replaced. You probably remember the ancient Egyptians, how they farmed along the Nile every year would flood, replenish the soil, and that process over time is sustainable. Now that's still used in some places. I'm sure the Nile is dammed now, so I'm not sure how much. I have to look into that. How much actual flooding is used to replenish that soil. The characteristics and formation of characteristics basically made out of rocks, air, water, and then organic matter. So that is what soil is made out of. Broken down rocks, about half of it, and the rest of it is mostly water and air, with some organic matter, dead stuff in it. And that's the thing, if you garden, you want that organic matter, that dead stuff in here. And the formation is just the erosion of rocks. Okay, over time, that's pretty much how it happens in all different kinds of ways, and we will look at. So here we have the parent material. So soil begins to form. To form, that's a T, not an F. We have water. See, it all starts with water. H2O is great at breaking things down, starting that process of whether it's your car, your house, your paint, whatever you have created, water kind of helps break it down. So if that falls on bare rock, that water helps start dissolving. It creates, those molecules moving. It helps start wearing that rock away. And later on, you'll have simple organisms that can then live in the soil. That little bit of rock layer that starts here simple organisms, organic matter, plants. Not just plants, but really important to remember bacteria living in the soil, fungi, protozoans. Write that where you can see it better. Worms. All little creepy crawlers, pill bugs, roly-polies, probably familiar with those. And over time, these different horizons form different layers. So layers, the official word is horizons. Horizons form. And this could take thousands of years, okay, for this to happen. And at least hundreds. And the, well, you know what? I think, yeah, hundreds of years. Put it in that time frame, you can have some rudimentary soil. Maybe not a lot, but some. And for it to all be washed away or blown away in a windstorm, it can just happen overnight. So therein lies the challenge, to keep the soil in its place while doing agriculture the way that we need to in order to feed people. And here we have well-developed soil here. This is what you want if you're going to try to grow something. Well-developed soil where you have the organic matter and then these different horizons. Usually you can see smaller, finer grains on top and then larger grains. The bottom A, B, C, and then the R, or the bedrock horizon. So I got plenty of diagrams. Draw all that out. So a couple different ways that soil it forms. This right here, when the parent material is the bedrock where it is made right in place, that's called residual soil. You know what a residue is. It's like the residue, like what's left over of that rock. Residual soil. And the parent, so this rock here is creating the soil. And then we have something called transported soil. It's broken down, eroded, transported. It's broken down, eroded somewhere else, and then it's carried somewhere else. Water, wind, ice, some other way, it's moved away from the parent material. Maybe we can put a note on that. Moved away from its parents. Yeah, add that to your slide. I like that. There we go. Better smelling. And I mentioned earlier, the Dust Bowl, this is what happened. Check out all this dirt. It's not supposed to be there. This is where the fence normally is, and all the wind has eroded. So what's this? Wind erosion. And this looks pretty sandy. This light color, and this is what we kind of get trained to figure out. This light color comes from a lot of sand usually. And that light color usually means there's less organic material. Not so much organic material. And the sandier soils, it has advantages, but disadvantages, like any kind of soil. The main parts of soil are sand, silt, and clay. And they all have a role to play. And you want a nice mix of all of those. But yeah, this slide definitely wind erosion, and that light color indicates a good amount of sand and not so much organic material. It's the organic material. If you've done a garden, that's what your fertilizer is, basically your compost. So I promised you, well, I don't know if I did, but mostly made out of minerals, aka rock. about 46%, about half, right? Organic matter is usually pretty small, about 4%, and the rest of it is air and water. If you just look at that, so look down the line, that's split in half. Yeah, you can make 25% and 25%. That might surprise you. 25% air. Yeah, but that's important. You need that air in there because the roots need to breathe. They need to exchange oxygen. So you might know if you water a plant too much, that can be problematic because there's going to be too much, you're not going to get enough oxygen near the roots. So let's move on to, here we go. The characteristics of soil, I guess the factors affecting formation. The number one thing probably is the parent rock, where it came from, right? Chemical properties, the minerals, iron, magnesium, copper, what does it have in there? Aluminum, the nitrates and phosphates. Those can be transported in the rock. Climate, what's the climate like? Is it wet? If it is, you have more erosion. Dry climates, there's going to be less erosion. And the temperature, does it freeze? That means you're going to have ice forming and cracking apart the rock. That'll have an effect. Relief, and that means mountains. Are there mountains, basically? We are a high relief area, meaning, in California here on the coast, we got low areas and we have really high areas. Boom, the mountains over here go 10,000 feet, just 30 miles away. Pretty big shift. So high relief. Florida, low relief. Texas, low relief. Colorado, high relief. So relief is that at altitude. The humus, that would be the organic matter, put O matter. And this would be like the flora, the plants, fauna, the animals, and any kind of microorganisms. Now let's go ahead, let's just clarify that because you might not be familiar with those terms. Flora, but people say these in everyday language sometimes, so you should know. And then time, how long has it been since that soil has been? Hundreds of years, thousands of years, a million years? Going to have a big impact on how that soil is formed. Now here we have the horizons, okay? Kind of the top, that's just the living stuff. We get into the real soil, we're looking at A, B, and C. Okay, so thankfully that's pretty easy to remember. It's nice when they make something easy to remember, right? I know, I appreciate that. So I gotta remember this stuff too. So the weather bedrock, that's on top of the regular bedrock. So if you drew another one, that's the bedrock. Solid rock underneath. Starting to weather. You got larger pieces right here where you have stuff that's kind of like trickling down from the top layers are going to accumulate. But really, this is the topsoil. This is kind of what we think of when we think of soil. Just that layer right under the top. If you just kind of push the leaves and stuff on top and grab those first couple of inches, that's the topsoil. It used to be on campus we could do this, but the construction made it possible. But maybe we can get some soil profiles figured out here. But yeah, organic matter, you see leaves, dead plants just laying on the surface. You see, dark color, like I mentioned before. That dark color, that's good. That's what, when even before you test the topsoil, planters, they'll look for that dark color, okay? And you'll see with less organic matter, it seems to get lighter in color. Lighter, less. organic matter. Now, let's practice this again. Remember the O, A, B, C, and then R. That's that bedrock. So, dang, I forgot to put it in here. What I want you to do is find a spot on your, let's go ahead and do this. Find a spot. I want you to draw and label your, soil profile. Go ahead, pause the video. You can use this one or this one. Slide 9 or 10, draw your own profile there. So you might have to put it on the back because I just added this slide. But that's doable. Or just slide a piece of paper in there. But you should have a little bit of space somewhere. Okay, let's see if we can finish this. Finish it up. So do that and then come back. So soil can be moved in a lot of different ways. Wind, water, ice. This first one, so rocks and minerals breaking down. That's the soil. But if the soil is going to move, it can be water transported. That's that first one. Water transported. Then it can end up in the lakes, in the streams, or in the oceans. It has some fancy words for that. I've never heard lacus stream. I've heard of alluvial. That's what you're looking at, alluvial plains, where a lot of our farmland in the world are grown in alluvial floodplains. And right here, this would be marine sediments. This over time, this is typically what turns into rocks, or sometimes it can turn into oil. If it's in the ocean, oil, coal, natural gas. The next one, we got gravity. And colluvial, I never heard of that either. So I'm learning a lot about soil. This next one is ice transport, like in glaciers. Like if you look at images of high mountain streams and Mount Everest, it's a really milky, light blue or kind of milky white color, almost like milk. And that's because of the little bits of rock that are in there. And if it's deposited by ice, it's called till, like glacial till or moraine. I'm really fascinated with glaciers and mountains like that. And the last one, we have wind transported. Kind of like what we saw on that slide with the fence, and, the fence and all the soil backed up there. Don't worry about memorizing all these here. It's kind of interesting. Just know these different ways the soils can be eroded and then moved around. So yet another diagram, but mainly here we want to point out to you each layer acts like a filter. So when water it ends up on the surface and then soaks through, it's called percolating. Water penetration, percolation. You're purifying the water. So if you let water sink into the ground, once it's in the ground, it's filtered. It's good water. It's not going to have bacteria, nasty heavy metals in it for the most part. So yeah, blocking particulate matter, and then bacteria as well, any kind of protozoan or any kind of creepy crawly microscopic thing. in the water, it's going to be filtered out. And that's what we do, what humans do to filter water. Most of the bottled water you use is going to be filtered somehow. You can buy filters like this. And I do an activity in our regular class too, where we filter the water. But yeah, this is just like, it basically, it mimics the natural world. Okay, kind of closely, you got thinner, smaller particles up top. We got larger particles at the bottom, just like we have in real life. Maybe we could try to make one. That'd be pretty cool. One time I did that and a student tried to drink the water. It looked so good. Flashlight, different kinds of erosion. This splash, this is what you have from each raindrop. Causes this splash. It's like a little bomb that goes off. Boom. You may have seen an image, probably should show one of just one picture, just one, slow-mo of a drop hitting, it creates force, it splashes out. This happens, this is kind of the smallest scale. The next smallest scale really is the sheet erosion. So water pooling and then running off the surface. In a sheet, the next biggest would be this rill where you have little you see these little mini rivers on the sheet. So mini. You've probably seen this after. I see this all the time when I go ride ride my bike on my trails in the mountains after it rains. I see this little rill erosion. And then the biggest, you see the larger scale with gully erosion, where you make like little gullies, okay, which are larger rills basically. Or large rills, or I say little valleys, little canyons, very small canyons maybe we'll say. And you can see over time that can happen and create bigger canyons, okay, with the water wearing it down and also the land rising up. That's what happened to make the Grand Canyon. You have the wearing, the Colorado River wore it down, but also the land rose up. So they work together to carve that canyon, which is awesome. If you haven't been to the Grand Canyon, you should really go. I know you'll love it. It just blows your mind. All right, so we are finished with 4.2. Thanks for hanging in on that extra long video. I just wanted to get it done.